Welcome back everyone to our channel Study with Adu. So yesterday was what a bar day for me, or it was Christmas, and I thought let all of us enjoy for just one day. We took a leave, but still I prepared videos for you yesterday, and I'll be posting it sometime soon. So today we'll be dealing with the chapter Amines. Amines from your class 12 chemistry. Amines. You know that this chapter amines really have two parts. Look, in your JEE main syllabus, this chapter's name is organic compound containing nitrogen. Organic compound containing nitrogen. This is the name of the lesson. Organic compound containing nitrogen. Okay. So we'll be learning about not only amines but also diazonium salts. That is, diazonium salts are salts like this. That is, these type of salts. We'll be learning about them. That way we are calling it organic compounds containing what? Nitrogen. We'll be learning about amines as well as on diazonium salts. So without much ado, we'll be moving on to our video. So everyone, please like the video now itself. And please subscribe to our channel. Please comment your opinion, doubts, suggestions, etc. in the comment section. Please, it's a request. It's like a down to earth request. You please. That's what I have to tell you. So without much ado, we'll be going on to the classes. Look, in the syllabus of JEE mains, it is given general methods of preparation, properties, reaction and uses. So general method of preparation. So preparation methods are there, properties and reaction uses. And in amines specifically, we should learn the nomenclature of amines. So for amines, we have to learn what all? We have to learn preparation, properties. Properties are both physical properties of amines are important, because the solubility is very different, comparably different, because in aqueous medium it's different, in gaseous phase is different. So physical and chemical both are important. Now we are having some important reactions, like what? Reaction with thionyl sulfonyl chloride, if I am not wrong, and reaction some important tests and all is there in this chapter. So properties, chemical properties are important. Then we have what? Yes, classification, that is primary, secondary, tertiary classification, and we'll be having uses. So this is what we have in amines. Now in diazonium salts, we have preparation methods, then reactions, that is properties, reaction. Example, Sandmeyer's reaction, etc. Then we have coupling reaction. That's the most important in diazonium salt. Coupling reactions. Then we have importance in synthetic organic chemistry, that is preparation of dyes and all. Example, that is same as coupling reaction, but it's told in a syllabus. Importance in synthetic organic chemistry. So this is what is there. So this is like totally NCERT based only, mostly NCERT based only. So our lecture will be NCERT based, because at the last moment we can't learn anything new. We'll just revise the things that is given in NCERT. Okay, that's the only thing possible for us. So now we'll be doing the lecture NCERT wise. So let me take NCERT of this chapter. So in amines chapter, first page, in the first paragraph, many things are given. You know that amines are there in proteins. What? Amino acids have amines and COH group. So amino acids, vitamins, etc. And amines are also present in which things? Dyes. That is not death. Dye means color dye. Okay. Then drugs, etc. Now it is given that two biologically active compounds, namely adrenaline and ephedrine, both containing secondary amino group, are used to increase blood pressure. So blood pressure is related with two amine containing compounds known as, you can just pass through, you can just write in your book the name of the compound, that is adrenaline and ephedrine. You can just note it and keep. So when you are reading your note for revision, you can just go through it, because we can't tell that, because as JEE is becoming simple day by day, they will ask this one word question and all directly, maybe they can ask. So ephedrine, so don't skip these things. Ephedrine. So these are the two compounds. Now we have next compound. This is used for blood pressure. Now we have another synthetic amino compound used as anesthetic, which is used as anesthetic. The compound is which is the compound? It's given in your first page, Novocaine. This is also an amine containing compound that is used as an anesthetic. Now we have quaternary ammonium salt used as surfactants. So quaternary, because look, uses of amines are told here, so it's important. Quaternary ammonium salts is used as what? Surfactants. As the surface chemistry chapter is released, you don't have nothing more about surfactants, but they are used as surface reagents. Okay. These are some important compounds containing amino acid, that is blood pressure increasing adrenaline and ephedrine, both contain amines, and anesthetic Novocaine contain amine, and quaternary ammonium salt acts as surfactant. This is about it. Now we are going to the first part of the chapter, that is amine. This is the first part, and this is the lengthiest part of the chapter. We are having two parts. One is amine, second one is diazonamide. First part, amine, is the longest part or most important part. So let us go with amine. Before going more into amine, we'll be just understanding what is primary, secondary and tertiary amines. This thing is the most basic thing of the chapter amines. What are primary, secondary and tertiary? Now why did I write tertiary here? Tertiary amines. Okay. Primary, secondary and tertiary amines. Primary amines, like when NH2 group is attached to only one carbon, it is directly attached to one carbon, then it is called a primary amine. Now if this N group, that is nitrogen, is directly attached to two carbons, then it is called secondary. Look, it is primary, secondary and tertiary. Tertiary amines are told on the basics of not on which carbon they are attached. Many of the people get confused here, because look, if this attached to the primary carbon, then it is primary. If it attached to secondary carbon, then it is secondary. That is wrong. It is like this. If N is attached to two carbons, then it is what? Two carbons, then it is secondary. If it is attached to three carbons, then it is tertiary. This is the thing you should understand. Okay, that's the basics of this chapter. Now classification is over. Now we have structure of amine. Look, they have given a big picture in the page number 260 of your textbook. Structure of amine. So structure of amine is important, very important. Look, from chemistry and all, for your entrance coaching centers, if you are going for entrance coaching, or if you are writing test series and all, they will give you tough questions, because they want to show that their entrance coaching center is great by giving tough questions. Look, for JEE mains examination, it will be not very much tough. Look, in 2024 the exam was very simple, comparatively simple. So this year also the examination pattern will be same as 2024, 2023. So it will be not that tough. But sometime this year they can make it some tough, like more, somewhat lower, like 5% tough than the last year, but after that they can increase the toughness according year. So this year you're comparatively safe, the toughness will be less. But if you're planning to drop 1 year and going to 2026, it may become tougher. Okay, before material, let us go to structure of amine. I'll be reading the paragraph written there. Like ammonia, nitrogen atom of amines is trivalent and carries an unshared pair of electron. You know that. Look. I'm taking an amine, NH. I'll be taking a tertiary amine. Like it's attached to 3 carbons, CH what? 3 CH3. I'm taking this carbon, this what amine. This is a tertiary amine. Look here nitrogen is having a lone pair because only 3 bonds are formed. Nitrogen will have a lone pair. This is a strain structure as in NH3. So this structure is what? What? This tetrahedral. You have learned that in NH3 the structure is tetrahedral. It's not the geometry, but hybridization is tetrahedral. Here the hybridization is tetrahedral. So how will be the arrangement? We have N here, we have CH3 here, we have CH3 here, we have CH3 here. Now we have the unshared pair of electron here. And the angle between this will be 108 degree. This angle is important. They can ask 108 degree. That's very simple because 180 degree is the normal angle between what? Not 108, it is usually 109 point something. But in this special compound, that is N, what? CH3N, the angle is 108 degree. Look, they have directly given it is 108 degree in case of trimethylamine as shown in figure 9.1. So they have given this angle. So this is important. Just to learn, just pass your eyes through it. You can answer. Now we have the next part, that is nomenclature. This is also told in the syllabus, so we'll just go through it. How we will name a compound in common system. Okay, very simple. What is a common name? How we will commonly name? That is common name. That is or trivial name. This is what that we commonly use. We name it as alkanamines. That is, if we are having this compound that is CH3 CH2 NH2. This compound can be named, it is ethyl group. So ethanamine. This is the common name. Now if we having any other compound, one second. 1, 2, this compound, that is 108 degree angle compound. Yes, this compound can be named as, how many methyl group are there? Tri. So trimethylamine. Not methanamine. So it is trimethylamine. Sorry, not trimethylamine. Sorry, what am I telling? Sorry. It is named as what? It is trimethylamine. It's a common name. Okay. Yes. Here, look, sorry, what did I tell you here? It is not the common name. The UPSC name is named like this. The common names are named like, if it is ethanamine, the common name will be ethylamine. Just write the alkyl amine. The other one is alkanamine. This is trimethylamine. This can be written as N, that is 2 nitrogen, 2 CH3 groups are attached to nitrogen. That's meant by NN. Instead of 1, 3, here 1, 3 position is not there. Attached to nitrogen, NN position is there. Nitrogen. So NN dimethyl, and 1 we will take it as a parent chain. If we are taking these two substituents in N, this will be the parent chain. This will be the parent chain, and hence we will name NN dimethyl methanamine. This is the IUPAC. Now you can name more compounds like this. Example, C2H5N, C2H5, CH2, CH3. How we'll name it? So it will be, look, consider the longest carbon chain as parent. So this is the longest carbon chain. So this will be the parent chain. The others having only 2 carbon. Here it's 4 carbon. So it will become N comma N. This is dimethyl. Diethyl. This is not propan. Butanamine. NN diethyl butanamine. You can name it as butan 1-amine, butan 2-amine, example. But it is butan 1-amine, so we will be naming it butanamine itself. If the compound was this thing, if this was the compound, instead of this was the compound. Yes, this was a compound. We will be naming it NN diethyl is same itself. Diethyl butan, which position? 1, 2. So second position, butan 2-amine. This is the answer. So this is about nomenclature. Now some important common names. That is, this is the most important common name. Yes, this is called aniline. That is its IUPAC name is benzenamine. You know that aniline is also a IUPAC name. Aniline is also an accepted IUPAC name. Okay. Now we will be looking some important common names. That is, if NH3 come here and CH3 group is here, this will be called 2-methyl aniline. So IUPAC name is 2-methyl. It's capital M. 2-methyl aniline. Its common name is O-toluidine. Orthotoluidine. Okay. Now if it comes as para, it will become P-toluidine. Okay. Simple. Sorry, if it is para position, we call it para-toluidine. So that's it. That is it. Now we'll take another compound. If it was bromine, it's NH2Br. What will name it? What do we name it? We'll call it p-bromoaniline. It's a common name. P-bromoaniline. That's para-bromoaniline. Or IUPAC name is 4-bromoaniline. Or benzenamine. Anything is preferred. So this is the compound. Now you can name it accordingly. It's simple. Now we will do one question from NCERT itself. That is question number 9.2 from NCERT. Index question. Okay. Write the structure of different isomeric amines. Isomeric structures of what should we draw? Isomeric structures of C4H11N. So we should draw the isomeric structures of this compound and write the IUPAC name of all isomers and what type of isomerism is exhibited by different pair of amines. That's what we have to write. We'll do it. So that is C4H11 thing. C4, that is, can be first compound is C4, CH2, CH2, NH2. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is the first compound. Next one. CH3, CH2, NH, CH3. Second compound. Now CH3. Okay, now we'll keep it between all the three. Okay, CH2, NH, CH2, CH3. Okay. Next one, we'll make it what? Branch wise. So what we'll do is that we'll take the first compound and make it branch wise and do. First compound is this one, it is butane. How will convert butane? We can make it like this, right? Like this, right? So first compound we will draw like this and add an NH2 here. Now we can also do it the other way, that is NH2 here. We can add NH2 only at these two places. So these are the two compounds. Now you can draw all these compounds. The answer for this question is given in NCERT itself. This question is very direct question, very simple question too. The answer to this question is given in what? It's not given in NCERT, but what you can do is that you will get NCERT solution books. You can look in that. Okay, look in that. The problem is that it's having many isomers. One second. So now we are having this isomer because the time is going too much, and these things are normally not asked in JEE examinations and CBSE examinations too. We'll be skipping this question and we'll be moving to preparation. How to prepare amine? There are 1, 2, how many methods? 1, 2, 3, 4, 5, 6 methods in NCERT. So we'll be only doing the NCERT methods that are the most important methods for the examination. So first method is reduction of nitro compounds. So you can take a nitro compound. I'm just taking nitrobenzene. You can take any nitro compound and you can add hydrogen in presence of palladium. Usually we use this hydrogen in presence of palladium for what? Reduction. And palladium in ethanolic medium, if we we get what? Reduced to product. It will be reducing to which thing? It will be reducing to amine. This is the first method inside the reduction of nitro compound. This is just by heart, this method. Okay. Now second method is that we can take a nitro compound. I'm once again taking nitrobenzene and I can add what? Tin plus HCl or iron plus HCl. Any one of these compounds, that is tin plus HCl or iron plus HCl, we get, it will be reduced. Because tin plus HCl is a reducing agent, it will be reduced to NH2. Here in SN plus HCl and Fe plus HCl, which is more preferred? I told anyone can be used. Which is more preferred? Here, which is more preferred? This is a very important question for board exam. Which is more preferred? Fe plus HCl is more preferred. Fe plus HCl is more preferred. The reason is that look, it's written in the paragraph below this. It's written there in NCERT page number 262. Reduction with ion scrap and hydrochloric acid is preferred because FeCl2 formed gets hydrolyzed to release hydrochloric acid during the reaction. So look, when this happens, there is a compound called FeCl2 created. In this case, FeCl2 created. This compound is very unstable. Okay, unstable, and it gets hydrolyzed. That is H3O plus hydrolyzed to what? Hydrochloric acid, HCl. So look, what happening is that the reagents are Fe plus HCl plus nitrobenzene, giving us what? Giving us amine. And look, now as FeCl is hydrolyzing to give HCl, we get HCl this side also. Now what is happening? We got HCl here also. Really, HCl is a reagent. What? A reactant. It's a reagent. Once again we are getting HCl formed here. So this HCl in the medium once again initiate this reaction, and more product we get. According to equilibrium approach, Le-Chatelier's principle. Equilibrium. Look what happened. We get HCl formed. So if we add 1 gram of HCl in the start of a reaction, 1 gram of Fe plus 1 gram of HCl in the start of the reaction, we should get some amount of NH2, that is some X gram of NH2. But we are using Fe and HCl as the medium, so we get HCl also formed here, some what x gram, some y gram HCl is formed. Look what happens here. Here we had 1 gram, here we had y gram. Totally now we are having y plus 1 gram. So more HCl is there. So therefore what happened? This x gram NH2 will be increased to some x plus z gram. That is more NH2 will be formed. That's the basic. Look, this stoichiometric coefficient 1 gram, 2 gram and all is just comedy. I just put for making you understand. It's not original coefficients and all. Okay, that's it. So Sn plus HCl does not have this property of creating HCl, so it is not that preferred. But Fe plus HCl creates FeCl2 that get hydrolyzed to Cl. So this is more preferred. Now we have the next process, that is second method, that is ammonolysis. Look, you read something and also written there that carbon halogen bond in alkyl halide is that stable, this stable is all written there. Let it write. Okay. Now what happens is that take a alkyl halide and add ammonia gas into it. Look, ammonia gas is having lone pair. X is electronegativity, X is electronegative. So it will having a minus charge, this will be having a plus charge. Look, here a plus charge is here a lone pair is there. Ayo lone pair, iso plus charge, lone pair, give its electron. Iso plus charge, lone pair, negative charge, seeing a positive charge. I love you. Lone pair is like, look, a positive charge. Look, really NH3 is like a rich man, a good rich man who's having money with him, that is electrons, money with him. Now when he is seeing a poor man that is having plus charge on him, this NH3 is a good man and is ready to donate his money to this poor person. So it's a NH3 is a good person. Now what happens is that we get R NH3 plus NH3. R will get this, and nitrogen shared one of its lone pair to R. Now you know that it had some money with it. Now nitrogen gave all of its money to another poor person. Now what happened? That poor person became rich, and this nitrogen who gave its money became poor. Now his money is given to R, so he will get a positive charge. Look, here something known as X minus left this place. X minus left. This X minus, so this positive charge. So it's like positive and negative can mutually interact without covalent bond, like a type of ionic bond can be happening. So this X minus go and stand near this NH3 plus, and we get a substituted ammonium salt. Substituted ammonium salt. This is important. Okay, okay, substituted ammonium salt. Now what I'm going to do is that I'm going to take this ammonium salt. That is RNH3 plus X minus, and I'm going to add an alkali into it, that is NaOH into it. What happens here is that here we get amine form, that is RNH2 plus plus H2O plus NaX. We get amine form. So what we should do is that first of all we added ammonia gas to a haloalkene. After that we get substituted ammonium salt. Into it we add a base, and we get what? Amine. We get what amine? Primary amine. 1 second. Sorry. So we are getting a primary amine. Now I am going to take this primary amine, and once again I am going to add what? RX. So what happens here, you know? Yes. One hydrogen will get removed, and we get RNH, and this R will go and join here, and we get a secondary amine. Now if we add one more RX, what happened? One more R go and join here, H will go with HX. So we get what? R. We get R. This can be some R dash, this can be R double dash also, no problem. Anything. R double dash, here it's R dash. So R double dash, R dash. Now into this once again if I am adding RX, what happens? One more time, does this R go and join there? No. Yes. One more time this R go and join here, because nitrogen is having lone pair. It's seeing a negative charge, a positive charge. Lone pair will be given to this R. So this R will go and join there. So it will become R, N, R, R, R. The problem is that now it gave its money or electron to it, so it will get a positive charge. Now this X minus is there in the middle. It's like, oh, I saw a positive charge here. Look here, no hydrogen also was released. Here there is no hydrogen, so HX will not be formed in this last step. This X minus is free in the medium. Now it's seeing this plus charge, so it will go and stand with it for forming an ionic bond. So we get R4N plus X minus. That is a quaternary ammonium salt. Ammonium salt. So this is the important reaction. Okay. Yes. And this quaternary ammonium salt is used as what? Surfactant. It's used as surfactant. Okay. So this is the ammonolysis reaction. Now this ammonolysis reaction is having some problem. Look, problem or disadvantage problem of ammonolysis. What is the problem of ammonolysis? The problem is that, look, first we got some RX and into that we added NH3. Okay, and we are getting some RNH3 plus X minus. Now into this we add this thing we got. Okay, it's acceptable. Now we added NaOH into it, and we got RNH2. The problem with that, still in the medium there is some RX left. You think some RX is left, unreacted RH is left. What happened? We needed primary amine. This primary amine is here, this RH is there. They react once again to form what? A secondary amine. The secondary amine once again reacts with RX to form tertiary amine. Once again reacts with RX to form quaternary ammonium salt. Now what is happening? There is a mixture of products. So what? Mixture of products are there. So what's the problem is that purification is difficult. And the thing is that purification is difficult because all is having the same constituents like nitrogen, carbon, no difference, no that much changes. So it's very difficult to purify. So this reaction should be under some controlled. So we should what we should do? Control the reaction. How to control the reaction? Now what we usually people do is that we take RX in a limited amount and ammonia excess. So what happens is that all RX will change it to RNH3 plus X minus all, because NH3 is in excess. So NH3 going to attack all R minus and no R minus is left in the medium. If R minus is not left in the medium, we'll just get a primary amine and we'll stop there. No need or formation of secondary, tertiary, quaternary ammonium salt and all is not there. If you take NH3 in excess, all NH3 go and attack the RX present in the medium and all RX is over. Now no more RX is left in the medium to react with the primary amine. So what we get? We once again get NH3 plus the X minus. Now once again RX NaOH is added. What we get? Primary amine. This primary amine don't have any more RX. No more RX left in medium. Therefore RNH2 we'll get it. What? We'll get it. We get primary amine as our product. Primary amine as our major product. That is primary amine as our major product. And what? No need of purification, no more reactants form. So we should use what? Excess NH3 to get primary amine as product. Okay. Now I told that this RNH3 with RX is going to react with what? NH3 to give you something called RNH3 plus and X minus. Now what we are going to do is that this RX, depending on which halogen atom is there, the reactivity is changing. So the reactivity order for RX is very important. For RX is RI, RBr and RCl. You think that RCl is what? electronegativity secondary most electronegativity and Ri. The problem is that I is a very big atom. I is a big atom. So it is, the bond length is too much. The bond length is more than RCl. Bond length, high bond length, bond. So easy breaking. That's the reason Ri is most reactive and RCl. Here bond length, electronegativity is high, but Cl and R are of comparable are small. Therefore what happens is that RCl bond length is very less. Hence bond enthalpy is high, difficult to break. That's the thing. So this is the reactivity of the haloalkane in the following reaction. Okay, yes. Now let us do the example question from NCERT. That is 1. Reaction of ethanolic NH3 with C2H5Cl. Ethanolic NH3 means in presence of what? Ethanol. Okay, that's it. So ethanolic NH3 and C2H5Cl. If ethanolic is given, no need of NaOH. Only ethanolic is there. So it's okay, no problem. So C2H5Cl plus NH3. Ethanolic, what happens? First step, it will be converted to we'll directly write it to C2H5NH2. No need to write the separately step. Now this is once again NH, what is added? We are adding what? C2H5Cl. Once again it is converted to C2H5NH, C2H5 secondary. Now once again we are going to add the C2H5Cl. Now it is going to convert it to be what? Tertiary amine, that is C2N, C2H5. Now once again if we are adding C2H5Cl, we get what? C2H5C, one second, C2H5N. So we get, I'll write it directly. That is 4 C2H5 will be there, right? So C2H5 4 times right, C2H5 4 times N plus X, that is Cl minus. This is the compound form. Okay, simple. Yes, it is simple. Now there's the second part of this question that you can do alone, the same method itself. Now third method of preparation, that is reduction of nitriles, that is cyanide group. So also important one. What happens? So we are having some RCN. I'll just write RCN. Into it we are adding hydrogen in presence of nickel, palladium or platinum. I'm taking nickel and what? Look, nitriles on reduction with lithium aluminum hydride or catalytic hydrogenation produces what? Primary amine. You can use what? Here next one is lithium aluminum hydride can be used, or you can also use what? NaHg C2H5OH. Ethanolic sodium amalgam can be also used. Okay, any of these three you can use to reduce it. What we get is that RNH2. Okay, not RNH2. One second. We get is that RCH2NH2. Here you look. This compound had one R group and Cn. Here Cn acts as what? Functional group. But here what happened is that the Cn bond break, then it became CH2. Here we got one carbon more in alkyl chain. So the speciality of this reaction is that one carbon atom is more than the reactant. That is, one carbon atom is more than the starting reactant. Here we had RCN, that is only R. When it became final, we got one extra carbon. That's the thing. So this is important. Now 4. Reduction of amides. Take amides, that is R C double bond or NH2, and you can use, you are only allowed to use lithium aluminium hydride first, then hydrolyze it, that is H2O, hydrolyze H2O. What we get is that RCH2. What is happening here? The H became very odd. RCH2 NH2 we get. This is, look, all are mostly what? Primary amine. All are mostly primary amines preparation. You know, really tertiary amine can only be prepared by which? Ammonolysis method. Mostly by ammonolysis method. Okay? Yes. This is reduction of amides. The thing is that here you can only use LiAlH4. Here you could have used anything, H2Ni, LiAlH4, NaHg or CO2S. But in nitriles case you can anything. But in amides case you are only allowed to use lithium aluminium hydride. Next reaction 5. Next reaction is the most important reaction, that is Gabriel phthalimide synthesis. Gabriel's phthalimide synthesis. Most important, one of the most important reaction. Gabriel synthesis is used for preparation of primary amines. Most important. Only primary amines can be prepared. Next point is that aromatic amines cannot be prepared. Okay. The reason for why we can't prepare aromatic amines, I will explain it while writing the reaction. Now what's happening is that the reaction is, take phthalimide. That's a compound that you have learned in which chapter? Alcohols and phenols you have not learned. In carboxylic acid we are telling about phthalimide. Okay. Take phthalimide. This is C double bond O NH C double bond O N. This compound, and into this compound add KOH, add ethanolic potassium hydroxide. Ethanolic potassium hydroxide. What happens that we get a potassium salt of phthalimide. Potassium salt. This is double bond O. Potassium salt, that is N minus K plus C double bond O. Now into this add RX, that is haloalkene. What happens is that this R go and join the N. And it will be C double bond O N R plus X is here, K is here. So plus KX. Now add NaOH, aqueous NaOH, aqueous medium. NaOH in aqueous medium, what happens is that please note, we get C double bond O Na plus, O minus Na plus, C double bond O minus Na plus. It will be breaking from there, and the left thing is what? R NH2. This is what? A primary amine. Only a primary amine can be prepared. Now why can't a aromatic amine be prepared by this method? Look, in this step an RX is added. If it is an aromatic amine we should add what? Haloarine. You know that this carbon and this bond is having what? A partial double bond character, and that's the only reason why Haloalkanes are what? Not reactive to what? What reaction? What reaction? Nucleophilic substitution reaction, right? So there's a partial double bond. There's a partial double bond character here. So it is very difficult to break a CX bond. Therefore, for this compound to form, this bond should be broken and this R should go and join here. But this bond breaking is what? Tough due to partial double bond character. Hence, this compound cannot be broken and the aromatic aldehyde, aromatic amine cannot be prepared. That's a thing. Okay, understood? Yes. Now next method, that's also an important method, that is Hoffman bromamide synthesis, bromamide degradation reaction. This is the last method in NCERT for preparing NH2, and by this method we'll be ending because we are mainly focusing NCERT. NCERT is the god for chemistry. NCERT is what? The god. Hoffman developed a method for preparation of which primary amines. Very important. Primary amines are prepared, not secondary, not tertiary. Primary amines, and here aromatic amines can be prepared, no problem. And okay, yes. So what's the reaction? First we should take an amide, Hoffman's bromamide. So amide we should take RC double bond or NH2. Into this amide we should add bromine gas and NaOH. What we get is that, just to learn this reaction by heart, best thing, we get RNH2 plus Na2CO3 plus 2NaBr plus H2O, 2H2O. This is the balanced reaction. Okay, so Br2 what? Amide plus bromine plus NaOH gives you primary amine Na2CO3, NaBr and H2O. This is the reaction. If you find, you can if you look, you can find something odd is that, look, the initial amide had a R group, RC. How many carbons? Look, or I will write an example. CH, I am taking ethanamide, CH3, CH2, not propanamide, CH3, CH2, C double bond O, NH2, and I am adding Br2 and I am adding for NaOH, and the degradation reaction happens, and I am getting CH3, CH2, CH2, NH2. No, I am getting CH3. This is not there. I am only getting ethanamine. So the product is 1 carbon less than this is having 3 carbon. Here the product only has how much? The amine only has 2 carbon. So what's the thing? Very important. The amine so formed contains 1 carbon less than that present in the amide. This is the most important thing of this reaction. 1 carbon less. In cyanide reaction, 1 carbon was more. In this reaction, 1 carbon is less. That's the thing. Okay. Yes. Okay. Now we will do some questions. And by doing that questions, we will end this session for preparation. Next session we will be doing on physical and chemical properties. So it will be a long session. Okay, it's very long session. We are having acidity, basicity and all. Then we are having many reactions. Then after that, third session will be on diazonium salt type. One second. So let us do some questions. You can try with me. Very important question. Basic questions only. Simple. Okay. CH3, CH2, Cl. First question is convert. You have to convert something to something. Convert CH3, CH2, Cl, 2, CH3, CH2, CH2, NH2. Look here, the thing having is 2 carbon. Here this has got 3 carbon. So something related with what cyanide is happening here because 1 carbon more, so cyanide. So first of all, convert this compound to cyanide by adding ethanolic NaCl. Ethanolic NaCl. You know that if you add NaCl or KCN, the compound, there will be what addition, what substitution? Yeah, nucleophilic substitution, and this becomes Cn. Now into this, what we should add? LiAlH4 or anything, LiAlH4 or NaHG, what, C2H5OH or H2Ni, you get what? CH3, CH2, NH2 as your product. Oh, sorry, I wrote 4. Sorry. CH3, CH2, NH2 as your product. This is the product. Okay. Yes. Now one next question. 2. Not convert. This is a complete a reaction. Design, something is there, then what happened is bromamide degradation, and we got what? We got propanamine as the product. What is this reactant A is the question. So look, you got propanamine as the product. You know that always the product is 1 carbon less than the reactant. So here for the reactant there will be, here there are 3 carbons. So for the reactant there are 4 carbon. With the 4 carbon you can write what? And with 4 carbon you can write what? And amide. That's the answer. That is CH3, CH2, C double bond O, NH2. This is the answer. Now another question is 3. I have taken what? I have taken chlorobenzene and I added phthalimide, and I added phthalimide, what? Phthalimide and KOH, then NaOH. What is the final product? B. Look, this is the reaction. What reaction is this? Gabriel phthalimide synthesis. And what is this? It is a aromatic halide or haloarine. This will not undergo phthalimide reaction, phthalimide synthesis. So what is B? No product. Okay, nothing will be formed. So these are the questions. Now another question 3, right? 4, which will be the other question? Let me check. Yes, convert benzene into aniline. Convert into aniline. Benzene into aniline. Okay, do it yourself. Simple. I'm giving you 2 minutes. I'm not pausing my video. I'm giving you 2 minutes in the video itself. Otherwise you may skip. Don't skip. Do it. Okay, so for this question, first take a benzene, then react it with the concentrated H2SO4 and HNO3, and we get what? Nitrated product. That is nitrobenzene. Now into this nitrobenzene add Fe plus HCl, reduction of nitrobenzene. We get aniline. This is the reaction. This is the reaction. Now another one. Benzene to NN dimethyl aniline. Okay, do. What should we do for this? Take benzene and react it with from haloalkane chapter. You have something from haloalkane chapter, how to convert benzene into haloarine, how to convert. Yes, once again I'll take that reaction and I'll tell the page number. In page number 166 you can convert it, right? One second, can we convert it? Okay, so we'll be doing the same reaction itself, that is concentrated HNO3, concentrated H2SO4, and then we'll add what Fe plus HCl. So we get what? We get aniline. Into this aniline what we will be adding? Add CH3Cl. So what we get? Add how many moles of CH3Cl? 2 moles of CH3Cl. Ammonolysis reaction. 1 mole means secondary, 2 mole means tertiary. So we get NCH3, CH3. This is NN dimethyl. Once again, not 3. Once again. 2 moles you can add. You get NN dimethyl aniline. This is the product task. Okay. So we'll be doing only this much questions. This is all from NCERT and some specific books, like simple question books. So this is on preparation of these compounds, that is amines. Preparation of amines. Now next session will be on physical properties and all. So everyone, please subscribe to channel, like our video, comment your opinions, doubts, etc. For sure I'll be replying to this. Please like the video. Now itself like the video. Thank you for watching the video. Thank you so much.